Hi everyone, this is about question 26. Okay, we look at question 26. Okay, actually this question they have two parts. They want you to find equation of normal. Okay, find the equation of normal. Okay, to the curve of y equals to x minus 2 over 1 plus 2x at the point whereby the curve cut as x-axis. Okay, what does it mean of cut at x-axis? Okay, when the question they say the curve cut at x-axis, that means your y will become 0. Okay, now second part of the question, they are asking find the coordinate of the point where this normal will cut the curve again. Okay, equation of normal. Okay, the question actually want you to find out the equation of normal with the point whereby they will cut again. Okay, for the second part of the question, maybe we look at it later on. We look at the first part of the question first, which I highlighted in yellow. Okay, first of all, when we look at this question, we need to find equation of normal. There are two criteria we need to fulfill. Okay, first criteria is we're going to have a point. Okay, what is the point they cut through? Second criteria, right? What we're going to do, we need to find out the gradient of tangent. Okay, from here we have to find out what is the gradient of normal. Okay, two things. So first of all, right, I will start off to find out point. Okay, where can I get a point? Now look at the last few words in the first sentence. They say where the curve cut as x-axis. So I already write down there when you cut at x-axis for the curve, that means your y equals to 0. Okay, we are able to find out what is the coordinate from there. Okay, so we start out with letting your y become 0. So what happened to your curve is become x minus 2 over 1 plus 2x equals to 0. Basically, your x minus 2 equals to 0. Your x equals to 2. So I find out my point, okay, which is 2, 0. Okay, done. First part. Okay. Now, second part, what we're going to look at it is, I'm going to differentiate the question. Differentiate the curve. To start off differentiate the curve, I need to identify, okay, my curve equations actually is a fractions. So we're going to use quotient rule to work out this question. So first of all, I'm going to let function u become my numerator x minus 2. Okay, function v, it become my denominator 1 plus 2x. Okay, now we start to differentiate. U prime equals to 1. V prime equals to 2. Okay, then we start to do dy dx differentiate. Quotient rule. For quotient rule, right, my denominator is v squared. So I'm going to put 1 plus 2x squared. Okay, now I start to differentiate. I will take v multiply with u prime. Okay, so I will get 1 plus 2x. Okay, minus of the second one, I'm going to take x minus 2 multiply with v prime 2. So from here I will get 2 bracket x minus 2. Okay, once I start out here, the next step is I'm going to take my point, the x coordinate of my point, which is 2, sub into the dy dx. So I will start with substitute x equals to 2 into my dy dx to find out my gradient of tangents. So my dy dx will equals to 1 plus 2 times 2 minus 2 bracket 2 minus 2 over 1 plus 2 multiplied by 2 and then square it. Okay, from here, right, I will get 5 over 5 square, which is equals to 1 over 5. So from here, right, actually this 1 over 5 is equals to gradient of tangent. So I can find out my gradient of perpendicular, or we call gradient of normal, by flipping my 1 over 5. Okay, flip my 1 over 5 and add the negative. So what it become? It become negative 5. Okay, now from here I got my two information. First information I get is my point is 2, 0. Second thing I got my gradient of normal is negative 5. So since I got these two information, I can sub into my equation of normal to find out the complete equation. Okay, so substitute, okay, 2 and 0, and m is equation of normal negative 5, okay, into my equation of normal, which is y equals to m perpendicular x plus c. Okay, this is to find out what is my intercept c, yeah. So we sub in my y as a 0 equals to negative 5 multiplied with 2 plus c. So basically my c is equals to 10. So therefore from here my equations of normal is y equals to negative 5x plus 10. Okay, now first part of the question is done. So let's have a look of the second part of the question, okay, which I already highlight the second sentence with in pink. Coordinate of the point whereby the normal cuts at the curve again. What does it mean? That means let's say our curve, right, will looks like this. Okay, you're going to find out the gradient of the normal whereby they will cut off again, either this point or this point. We don't know yet, so we're going to find out. How we're going to do it is we're going to set up my original curve equation as equation 1, okay, and also my equation of normal as equation 2. So first of all, I will use my first part of my answer, y equals to negative 5x plus 10 is equation 1. Okay, my equation 2 will be my original curve equation, y equals to x minus 2 over 1 plus 2x, equation 2. Okay, using simultaneous, making them equal to each other. So what I get is x minus 2 over 1 plus 2x equals to negative 5x plus 10. Okay, next step, I'm going to bring over my denominator x plus 2x, 1 plus 2x multiplied with negative 5x plus 10. Okay, so I will get x minus 2 equals to 1 plus 2x, okay, minus 5x plus 10. Okay, from here I start to do my expansions. Okay, what I get is 10 plus 20x minus 5x minus 10x squared. Okay, rearrange everything from of my term on my right hand side to the left hand side. Okay, by collecting the like term, I will get 10x squared minus 14x minus 12 equals to 0. Okay, thereafter I factorize my quadratic. So from here I get my x minus 2. Another one is 10x plus 6. Okay, when we look at this question, okay, my x minus 2 is equals to 0. Another one is 10x plus 6 equals to 0. Okay, from here, right, I notice my x equals to 2, which is same as the point that I found out in part 1. So I can reject it. This is not the point that I'm going to cut at the curve again. This is my point that I found from my part 1. Okay, so I'm going to solve out my x coordinate for the other side. So from here, right, I will get my x is actually equals to negative 6 over 10. Simplify it is negative 3 over 5. Okay, I found my x coordinate of my point. So what I'm going to do is, the next step, I'm going to substitute my x coordinate negative 3 over 5, okay, into, okay, this one I will sub into my first equation. That means I will sub into my equation of normal. So what I get here is y equals to negative 5 bracket negative 3 over 5 plus 10. Okay, cancel my 5 and my negative become positive. So my y will become 3 plus 10, which is equals to 13. Therefore, okay, another point whereby they're going to cut at the equation of normal, which is negative 3 over 5 and 13. Thank you.